In this video, we're going to talk about the Signum function. And the Signum function is unique because at its most basic level, here you have it as the signum or sign of just x. At its most basic level, no matter what x value you put in, the y value is going to be one of three choices: positive 1, 0, or negative 1. Specifically, if you input an x value that is positive, let's say you input positive 7 into that function, then the result is going to be positive 1. Here you see an input of positive 7, and you go to the graph, and the y value is positive 1. On the flip side, if you put a negative value in here, negative 25, if there's a negative value inside those parentheses, the result, the y value, the output is going to be negative 1. So here we have an x input of negative 25, and the y output is negative 1. Finally, if you plug in 0 for x inside that parenthesis, then the sign function is going to give you a y value of 0. Now, three choices: +1, 0, or negative 1 for the y value. Now, compare and contrast that simple function with these two examples. Okay, here's where things change up a little bit. Here, the final y value is still going to be negative 1, 0, or positive 1. However, it's not going to be as straightforward. In other words, when you input an x value, say an x value of negative 2, you have to have this inside function work on this and determine whether this final result is positive or negative. So here in this case, if we plug in x equals negative 2 into this function, we're going to get negative 4 minus 4 is negative 8. And in this case, your output is going to be negative 1. If we put positive 1, x equals positive 1 into here, we plug that into the inside function. This inside function works on that input, which is positive 1. The end result is a negative 2. This output is also going to be negative 1. So here we had a scenario where you plugged in a negative value initially for x, and the y value was negative 1, and you put in a positive value in for x, and still the final result y value was negative 1. Now, folks, we have this third scenario where this portion of the function right here is going to yield an output of either positive 1, 0, or negative 1. But then these neighbors here, you're going to be multiplying, here you're going to be adding, are going to affect the final output. So in this graph, k of x, your y values will be different than negative 1, 0, or positive 1. Specifically, it's either going to be 3 times positive 1, which is 3, plus 7, which is 10. 3 times 0 is 0, plus 7, which is positive 7. And finally, 3 times negative 1 is negative 3, plus 7 is positive 4. So 3 different scenarios. But the important thing to realize is that this portion of the function, the SGN and the parentheses, is going to spit out a y value of +1, 0, or -1. And there are only going to be 3 outputs from this portion, and those 3 outputs are going to change from positive 1, 0, and negative 1 to different results based on whether or not there is something in front here or something in the rear here. Here we have a graph of the sine function on GeoGebra. For some reason, I find GeoGebra easier to work with than Desmos with the sine function. So here we go, the most simplistic version. There's nothing else inside the function other than x, and there's no neighbors in the front or at the end. And here we can see there's only 3 possible y values. Here, y equals 1. For all these x inputs, the y value stays 1, or the y value is at 0, or the y value is at negative 1. In this first function, we have the signum of 3x plus 2. Okay, the fact that there's no neighbor in front, there's no neighbor here to the right, we know that the output of this function is going to be one of 3 results. It's either going to be positive 1, negative 1, or 0. So here, I'm ready on my graph for that. I have positive 1 and negative 1 marked out, and then we're going to have a 0, y equals 0, and we're not sure where that's going to be yet. So let's plug in some x values. If we plug in, excuse me, x equals positive 10 into that parentheses, the function inside the parentheses is going to work on that positive 10, and the end result is going to be a positive number. Therefore, the final y value of the function is going to be positive 1. So we know if x input is plus 10, the y output's going to be positive 1. Okay, let's now put a large negative number in here. Let's plug in negative 5. So we're going to plug in negative 5 into that x value. This function within the parentheses is going to munch or work on that negative 5, and the result is going to be negative 15 plus 2, negative 13. Because that's negative, the y value is going to be negative 1. So we know that when the x value is negative 5, the y value is going to be negative 1. Now let's pick a number, x equals negative 2. If we plug in negative 2 in here, we're going to have negative 6 plus 2 is negative 4. Still going to be negative. Our value is still going to be negative 1. When x equals negative 2, the y value is still going to be negative 1. Now, what if we put a value of x equals positive 1 in here? So positive 1 is going in. The inside function is going to work on that, and we're going to get positive 6, so it's still going to be positive 1. But look what's happening here, folks. We're coming to a critical position here where these values for x result in negative inside the parentheses, and these values of x result in a positive value inside the parentheses. That results in a y value of negative 1 and a y value of positive 1 respectively. But the question is, what's the switch point? At some point, at some value of x here, they're going to switch. So the question is, what value of x right here changes the inside of that parentheses from negative to positive or vice versa? So how do we find that critical point right there in the x-axis that's going to cause the sine function to flip from an output of negative 1 to positive 1? Well, folks, the answer is we set that equal to 0. So we take that parentheses and set it equal to 0. 3x plus 2 equals 0. We're going to get x equals negative 2/3. So when x equals negative 2/3 right here, that is going to be 0. The sine function is going to be 0. So we're going to put a closed circle at the point x equals negative 2/3, comma, y equals 0. Now we can extend these graphs all the way to x equals negative 2/3, but put an open circle, and we extend this bottom graph all the way to x equals negative 2/3 with an open circle, and folks, that is your graph. So the way to do these is to set the parentheses equal to 0. Find the x value that renders this parentheses 0. That becomes your critical point. And then anything to the right of that you plug in will result in a positive value, resulting in an output of +1. Anything to the left of that critical point will result in a negative value in the parentheses, which results in a y output of -1. Next, we are asked to graph this function here. Now, notice this function has neighbors. There's one out front and there's one in the rear. That means the final graphs here are not going to be +1, -1, and 0. They're going to be influenced by those two integers. However, here's what we do know, folks. We do know that this portion of this function is going to yield either a +1, a 0, or a -1. So when these integers act on these values, we're only going to get 3 possibilities. We're going to get 3 times +1 is 3 plus 2 is +5. We're going to get, this is 0, 3 times 0 is 0 plus 2 is +2. And the final is, if this is what spits out a -1, we're going to get 3 times -1 is -3 plus 2 is -1. So these are going to be our possible y values coming out of this function. Now, the question is, where's the transition? Where does this jump from -1 to +2 and then to +5? Where's the critical point where that's going to happen? The answer is the x value that makes this 0. So we're going to take the inside, we're going to set it to 0, we're going to solve for x, and that's going to tell us when x equals +1 as an input, the output is going to be +2. Why? Because when x equals +1, this parentheses goes to 0. The sign function of 0 is 0. Then these two integers act on the 0. 3 times 0 is 0, plus 2 is a y value of +2. Now it's easy. These are going to be open circles. Now, for completeness sake, we're going to put in an x value over here and see whether we get a +5 or a -1. So let's put in an x value, a test value of x equals +10, way out here. If we plug in +10 into that function, the parentheses becomes positive. This entire pink box becomes +1. The integers now act on the +1. 3 times +1 is 3, plus 2 is 5. So we know that's our point right there, and we can go ahead and extend the line. And if that's true, then we know that this other line is going to extend like so. Just to make sure, let's plug in an x value way out here. Let's plug in x equals -5. If we plug in x equals -5 into that parentheses, the parentheses becomes negative. The sign function of a negative value in the parentheses is going to yield -1. These integers are then going to act on that -1. We're going to get 3 times -1 is -3, plus 2 is -1. Therefore, the y value is going to be -1 as shown in this portion of the graph. This next and final example, we see a lot going on here. We see a function within the parentheses that we're going to have to deal with, and we see two neighbors. We have the -1/2 out in front and the -4 in the rear. Folks, we know that this rectangular box is going to yield one of 3 outputs, +1, 0, or -1. And then these neighbors are going to act on them. If the sine function, if this rectangular box yields a positive 1, we're going to have negative 1/2 times positive 1, that's negative 0.5, minus 4, that's going to be negative 4.5. So let's go ahead and begin our plot. We know that one of the y values is going to be negative 4.5 down here. Okay. If this rectangular box yields 0, we're going to have negative 1/2 times 0, which is 0, minus 4 is negative 4. So that's another potential end y value. And finally, if we have negative 1 emerging from this rectangular box, meaning if the x input results in a negative value in the parentheses, then the sine function is going to output a negative 1, and now the negative 1/2 is going to be multiplied by that. We're going to get positive 1/2 minus 4. We're going to get negative 3.5. Obviously, this is not to scale. Now, folks, the question is, where's the critical point? Where do these changes start happening? And to find that critical point, to find the critical x value that makes the whole graph change from a y value of negative 4.5 to negative 4 to negative 3.5 is determined by setting the parentheses equal to 0. So we're going to set 3x plus 2 equal to 0, solve for x, and we're going to get x equals negative 2/3. So we know if that's 1, negative 1, excuse me, and we have an x value of negative 2/3 here, we know our y value is going to be negative 4. Again, at negative x equals negative 2/3, the parentheses is going to go to 0. The sine function of that 0 will be 0. Negative 1 times 0 is 0. Minus 4 is negative 4. There's your y output. We now know there's going to be open circles here at negative 3.5 and at negative 4.5. Now, the question is, which way do our lines go? Are they going to go, is this going to go to the right or the left, and vice versa? So to do that, we plug in extreme points. So let's take an x value way out here. Let's use positive 10. So if we put in an x value of positive 10 and we insert it into this parentheses, we're going to get 30 plus 2 is positive 32. That's going to yield, because that's positive, this rectangular box is going to yield a positive 1. So now we're going to have negative 1 times plus 1 is negative 0.5 minus 4 is negative 4.5. So that positive 10 is going to have a y value of negative 4.5. As a result, we feel confident connecting these points as so. If you want to double check it, we could put in x equals 0. If you plug in x equals 0 here, you're going to get a positive value. That's going to result in a positive 1, and you're going to get the same ultimate y value of negative 4.5. Okay, just to double check, let's put in an extreme negative value. Let's put in negative 20 for x over here. If we sub in x equals negative 20, this parentheses is going to go to a negative value. The sign of the negative value is going to result in negative 1. Negative 1/2 times negative 1 is positive 1/2, positive 0.5, minus 4 is negative 3.5, and this is your final graph. Let's go ahead and look at GeoGebra. I mentioned I like GeoGebra better than Desmos, and here we go. Here's our critical point A. You could see our critical point here is negative 2/3 comma negative 4. Here's our function that I entered. We see that there's going to be an open circle here, and the graph is going to be extending to the left. All these y values are negative 3.5, and here all the y values are negative 4.5.